So, hello student. In the series of revision classes, in the last video, I have started the chapter motion of body in a straight line or a kinematics. Okay. Now today, firstly, I will discuss the some topic which are left in last video, and after that, I will discuss sub question. Okay. So the first topic is here force. So force is defined as the push or pull which changes or tries to changes the position of any body is called force. Okay, so a push or pull of an object is known as force. A push or pull of an object which changes or tries to changes the position of a body is called force. Now next is what force can do. Force can start or stop an object. Next, force can change the speed of an object. And third one is force can change the direction of motion of an object. And fourth one is force can change the shape of an object. So what is the force? Force is generally a push or pull of an object which can start or stop an object, which can change the speed of an object, which can change the direction of an object, which can change the shape of an object. Now there are two theories. First theory is Aristotelian law of motion. It states that an external force is required to keep a body in motion. Okay, simply it say that an external force is required to keep a body in motion, but Galileo proved it's wrong. Okay, so Galileo studies motion of an object on an inclined plane. Firstly, it will study about the object moving downward on an inclined plane. If an object is moving downward in an inclined plane, so its speed increases. And second case is that if an object is moving upward on an inclined plane, its speed decreases. And third is that if a motion of an object on a horizontal plane, so its speed remain constant. Okay, so what he conclude from here that a motion that a force is required to keep force is required to counter the opposite force of friction, not required to keep the body in motion. A force is required to counter the opposite force of the friction. Okay, so after that he will give law, the law of inertia, which later we called as Newton first law. So what is the law of inertia? It states that a body is moving with a certain speed along a straight line, continue to move with the same speed along the same straight line path in the absence of external force. Simply, it is saying that if a body is in rest, so it will remain in rest. And if a body is in motion, so it will remain in motion unless an external force acts on it. Now, next is what is inertia? So the inertia is the inherent property of a material or body by virtue of which it cannot change its shape, state of rest, or of uniform motion in a straight line. So that was called inertia. So there are three types of inertia: inertia of motion, inertia of rest, and inertia of direction. Firstly is inertia of rest. Inertia of rest means the tendency of a body to remain in its position of rest is called inertia of rest. Means in this one, a body is want to remain in its position at of rest. Okay, so what happened on that? What are the example of that? So a person is sitting in a car, get a backward jerk when the car suddenly started. So suppose that was the person that was sitting in the car. So what will happen? Its upper part when car will start it. So its lower part move forward and its upper part will remain in the rest. So that's why when car suddenly started, so it experience a backward jerk. Okay, so that was the inertia of rest. Next is inertia of motion. Inertia of motion is the tendency of a body to remain in its state or of uniform motion in a straight line is called inertia of a motion. Suppose that was a man sitting in the car and a car is moving. Suddenly the car stops. What happened? Its upper part of a body is in motion. Okay, it want to remain in motion. but the lower part of a body suddenly started. So that's why it experienced a forward jerk. So that was the inertia of motion. Okay. So inertia of direction. The inability of a body to change by itself its direction of motion is called the inertia of direction. Okay. Inertia of direction means if a body want to change, suppose if a person is sit in the bus, so what will happen in the curve road? Bus is moving that way and person is sitting force that one, that side. Why person is getting force on that side? Because the body of the person wants to remain in the same direction, but when the car is move on the when the buses move on the curve road, so it will receive a force on that direction, means outward direction. Okay. So that was the inertia of direction. Now what is the relation between mass and inertia? Simply you can say that mass is inversely proportional to inertia. More the mass, more will be the inertia. So the mass of a body is a measure of its inertia. If a body has more mass, it has more inertia. It is difficult to change its state of rest or of uniform motion. Okay. So suppose if we kick a football, it flies a long way. And if we kick a stone of same size, it hardly moves. Okay, so that was just the relation between mass and inertia. Now comes to Newton's first law of motion. So according to Newton's first law of motion, every body continues in its state of rest or of uniform motion unless an external force act on it. Okay, means simply you can say that if a body is in a rest, so it will remain in a rest, and if a body is in motion, so it will remain in a motion. So that was the Newton first law of the motion. Now the example of Newton first law of motion is when a horse suddenly start running, the rider fall backward. And second one is dust is removed from a hanging carpet by beating it with a stick, because the particle want to remain in a rest. When we beat the carpet with a stick, so the carpet is in motion. So that's why they will that why they will comes like in a straight line. Simply when we shake the branch of a tree, its fruits and dry leaves falls down. So that are the example of Newton's first law of motion. Now comes to the main part, that was momentum. So the momentum of a body is defined to be the product of mass and the velocity. And the formula of momentum is mass into velocity. It is a vector quantity. Its SI unit is kg meter per second, and its dimension is mlt minus 1. And the momentum of a body is the quantity of motion possessed by the body. Now second one is the graph of the momentum. When the mass is constant, we know that P is equal to mv. When mass is constant, so P is directly proportional to V. So the graph between them will be a straight line. Okay. Second one is when the mass will be constant. So what will happen when, when the velocity will be constant? So P is directly proportional. Again, we get a same line. Now, second one is when two bodies of unequal masses m1, m2 have same momentum. Means P1 equal to P2 and m1 equal to m2. So what will happen? m1 v1 equal to m2 v2. Okay, so m1 upon m2 ratio is equal to v2 upon v1 ratio, means mass is inversely proportional to v. So the graph between them will be a like that, graph of 1 upon x. Okay, now next is Newton's second law of motion. Many of the students have answered that what is the Newton's second, sorry, when we ask about the Newton's second law of motion to the student, many of the students says that Newton's second law of motion is F is equal to ma. But that's wrong. That is the result of the second law of motion, not a second law. Newton's second law of motion states that the force is directly proportional to rate of change of momentum. That means F is equal to d. F is directly proportional to dp by dt. Okay, F is directly proportional to dp by dt. When uh, we remove the sign of proportionality. A constant is came which is equal to 1. So F is equal to dp by dt. We know that P is equal to mv and mass is always constant. So F is equal to d by dt of mv. So mass is always constant. So d by dt of v. So d by dt of v means the rate of change of velocity, which is equal to the acceleration. So F is equal to ma. So F is equal to ma is not a second law of motion. It was a result of the second law of motion. Second law of motion is simply that F is directly proportional to rate of change of momentum. Okay. And what is the momentum? Momentum is the product of mass and velocity. And one more definition of momentum is here, that momentum of a body is the quantity of the motion possessed by the body. Okay, momentum of a body is the quantity of the motion possessed by the body. Now next is your impulse. The force have SI unit Newton, CS unit time, dimension formula MLT minus 2. Now next is your impulse. Impulse is a large force acting for a short time to produce a finite change in momentum. Okay, means simply it is denoted by J. J is equal to force into time duration. You have seen in the many example in your book the cricket player lower his hand when he catch the ball, or automobile are provided with shockers. All are the example of impulse. So force exerted on a bat while hitting a ball, blow of a hammer on a nail. Okay, shockers on a automobiles. All are the examples of impulse. So it is defined as the product of force and the time duration for which it acts and is equal to the total change in momentum. Okay, so impulse has two formulas. It is equal to the force into time duration and the change in momentum. Most important part is that you have to prove that theorem, that is known as the impulse is directly proportional to impulse is equal to change in momentum. You can simply say that impulse momentum theorem. That's what's very important for your exam point of view. Okay, so the formula of impulse is force into time duration. So its SI unit, force have SI unit of Newton, time as SI unit of second. So SI unit will be Newton second. And the dimensional formula will be, we know that the force have dimensional formula MLT minus 2 and time duration is T. So MLT minus 1 will be the formula for, dimensional formula of impulse. Now comes to impulse momentum theorem. Impulse momentum theorem states that the change in momentum is equal to the impulse experienced by the body. So J is equal to delta P. Delta P means P final minus P initial. Now we know that F is equal to ma. How we can prove it? Now see here. We know that force is equal to mass into acceleration, and acceleration is equal to change in velocity upon time. So F is equal to m of v minus u by t. Now Ft equal to mv minus mu, where mv is p final and mu is p initial. I think the screen is not visible. Wait, huh? Now see the proof of impulse momentum theorem. We know that force is equal to mass into acceleration, and acceleration is change in velocity upon time, m v minus u by t. Now cross multiply, ft equal to mv minus mu, and we know that the momentum is mass product of mass and velocity. So p final minus p initial is equal to impulse. Okay, so J is equal to change in momentum. That was your impulse momentum theorem. Now next, you can prove by this method, or you can prove it by integrating method. So what is the integrating method? Now second method, that was the integration method. Prefer this method in your examination. Okay, second method is calculus method. By calculus method. By calculus method. We know that F is equal to dp by dt. According to Newton's second law of motion, force is rate of change of momentum with time. So F dt equal to dp. Okay, by cross multiplying. When t is equal to 0, that means when time is equal to 0, so the momentum will be initial momentum. And when time is equal to t, the momentum will be the final momentum. So you can integrate within the limit of time and momentum to this equation. So integrating above equation within a limit of time and momentum, within a limit of time and momentum, within a limit of time and momentum. Now integration of f dt is equal to integration of dp. What is the limit of time? 0 to t. And what is the limit of momentum? P initial to P final. Now f come outside, integration dt 0 to t is equal to integration dp of P initial to P final. Now integration is removed by the differentiation. So ft is 0 to t and dp is p, which is from p initial to p final. So f is t minus 0 and p is p final minus p initial. So ft is equal to p final minus p initial. Ft is impulse. So J is equal to P final minus P initial. That was your change in momentum. So J is change in momentum. Okay. So that was your impulse momentum theorem. Now, if you have given a graph, so how you can solve? So in the graph, there are two types of graph. First one is when a constant force is given, when a constant force acts on a body, when a constant force acts on a body. Suppose that was your graph. This axis is of time. This axis is of force. Now, suppose a constant force acts for a short time from T1 to T2. That was your constant force. Okay. It was acts for a smaller time, T1 to T2. So how you can find the impulse? So in that case, impulse is equal to area under FT graph. Area under FT graph. So that's area is known as your impulse. Okay, when a constant force is given. Now come to the next case, when a constant force is not given, when a variable force is given, when a variable force acts on a body. So what will happen? Suppose that was the variable force acts on the body. That axis was time. That axis is of force. So on the variable, when the variable force is given on the body, so it was like that graph, T1 to T2. Okay, means in that case force is not considered. So what you can do, you can make strips and then you can add. Simply means I am saying that you can do it by integration. So in that case your impulse will be T1 to T2 f dt. Okay, so that was the two graph which will came in your question, which can be came in your question. First one is of when a constant force acts on a body, so how you can find the impulse, and second one is that when a variable force acts on a body, so how you can find the impulse. Okay, now that was given in the PDF. So according to this theorem, that was the proof of impulse momentum theorem. Now the practical application of impulse. A cricket player lower his hands while catching a ball. Why he was lowering his hands? Because we know that J is force into time, impulse is force into time. If you have if impulse will be constant, so force is inversely proportional to time. So lower his hands means it was increasing the time. If it was increasing the time, so the force experienced on his hand will be lower. So that's why it will receive less force on his hand, so it does not hurt him. Secondly, a person falling from a certain height receive injury when he falls on a cemented floor, because in a cemented floor, if a person is fall, so there will be a short time duration. If a time will be very short, so force will be high, so there is more chance to get the injury. But in a heap of a sand, a person is fall, so this heap goes some downwards, means it increases time. If it increases time, the force will be less, so there will be a less chances to receive an injury. Now, next is automobiles are provided with the shockers. All are the examples of impulse. Now comes to the Newton's third law of motion. According to Newton's third law of the motion, to every action there is equal and opposite reaction. While we are walking, we are the Newton third law of motion acts. While we are swimming, Newton third law of motion acts. Books kept on a table are the example of Newton third law of motion. So that's all are in this chapter. Now come to the numerical part, which had come in your previous year. Okay, so I am solving question one by one. The first question is, a batsman hits a batsman hits back ball straight. Sorry, a batsman hits back a ball straight in the direction of the direction of the bowler without changing its initial speed. Without changing its initial speed. Its initial speed of 12 meter per second. If the mass of the ball is 0.15 kg, determine the impulse imparted on the ball. Determine the impulse imparted on the ball. The impulse imparted on the ball. Now see here the condition. Suppose that was the bowler that threw a ball to a batsman. Okay. After hitting, after hitting that ball by the batsman, what will happen? A batsman hit back a ball without changing its initial speed. So what it means, that your initial speed and your final speed have magnitude equal to 12 meter per second. Okay, and mass of the ball is fixed. Mass of the ball is fixed always, so 0.15 kg. So what will happen? Firstly, the velocity of ball when bowler throw is 12 meter per second. After hitting, the ball come with the same speed, but in that case the direction will changes, and the direction will changes. So we will apply here minus sign. Okay. So what will happen? So according to Newton, according according to law of conservation of momentum, law, sorry, wait. Determine the impulse imparted on the ball. So impulse is defined as the change in momentum. Change in momentum. So what is the change in momentum? P final minus P initial. P final minus P initial. What is P final? Mass into the final velocity into mass into the initial velocity. So what is the final velocity will be 12 meter per second. You can take minus sign here, and minus of m of 12 meter per second. So the mass is also given. The mass of a ball is 0.15 kg. Okay. So the mass is here 0.15 kg. So 0.15 into minus 12 minus 0.15 into 12. Now if you take 0.15 common, so minus 12 is equal to minus 24. So 0.15 into minus of 24. So you will get minus 3.6 Newton per second. Sorry, minus 3.6 Newton second. That was the value of J. If you take the mod, so you will get 3.6 Newton second. Okay, that was your answer. Now next question is your a man walks on a straight road. A man walks on a straight road from his home to market 2.5 kilometer away with a speed of 5 kilometer per hour. Finding the market closed. Finding the market closed. He instantly turns. He instantly turns and walk back to home with a speed of 7.5 kilometer per hour. What is the magnitude? What is the magnitude of average velocity and average speed? What is the magnitude of average velocity and average speed of a man over the time interval over the time interval 0 to 5 minutes. Time interval 0 to, sorry, 15 minutes. Now, a man walks on a straight road from his house, from his home to market, which is 2.5 kilometer away, with a speed of 5 kilometer per hour. So we know that the speed is equal to distance upon time. Speed is equal to distance upon time. So time is equal to distance upon speed. So what is the distance when he goes from when he goes from his home to market? So the distance will be 2.5 kilometer. And what is the time required? Sorry, what is the speed? Its speed will be 5. So after removing the sign, you will get 1 upon 2 hour. That means in a half hour, he goes from his home to the market. Now the second condition, while finding the market closed, he instantly turns and walk back to home with a speed of 7.5 kilometer per hour. So what is the time required when he instantly return with a speed of 7.5 kilometer per hour? Distance is same, 2.5, and the speed will be 7.5. So the time will be 1 upon 3 hours. So the total time of his journey is 1 upon 2 plus 1 upon 3. That was your 6. So 3 plus 2. So 5 upon 6 hour required in its total journey. Okay. 5 upon 6 hour means 5 upon 6 into 60 minutes. That means 50 minutes. So it will require 50 minutes to go from home to the market and come from market to home. So in the 50 minutes, your average displacement will be 0. Why? Why? Because in that case, your final point and initial point will be same. He goes from home to market after seeing the market is closed, so he is instantly returned. So that's why he came to its final point. Means at that point, your final point and initial point are same. So the average displacement will be 0. And if average displacement will be 0, so average velocity will be the total displacement upon total time. There will not be the average time, that will be your total displacement. Okay. So average velocity will be total displacement upon total time taken. Total time taken. Okay. So the total displacement is 0 and total time is 5.6 hour. So it is equal to 0. Now the speed, average speed. How we can find the average speed? Average speed is total distance upon total time. Average speed is equal to the total distance upon total time. So what is the total distance? Suppose that was the point, that was his home, that was his market, that point was market. So he goes from home to market, which was 2.5 kilometer away, and after returning, he will cover same distance 2.5 kilometer. So 2.5 plus 2.5 will be the total distance, and the time is 5 upon 6 hour. So 5 upon 5, and that 6 come in the numerator. So average speed will be 6 meter per second. Okay, sorry, 6 kilometer per hour. 6 kilometer per hour. Okay, that are in your kilometer, that are in your hour. So its average speed in 0 to 50 minutes is 0 kilometer per hour, and the average velocity will be 6 kilometer per hour. Average velocity will be 0, and average speed will be 6 kilometer per hour. Now next is Now the next question is, a car moving along a straight highway with a speed of with a speed of 126 kilometer per hour is about to stop within a distance of 200 meter. Within a distance of 200 meter, if sorry, what is the retardation what is the retardation of the car and how long does it take to the car to stop to the car to stop. Okay. So that was the car. It was moving with a speed of 126 kilometer per hour. When we apply brakes, so what will happen? It will stop at that point. Means at 200 meter, it will stop. So on stopping, what will be its velocity? Its velocity will be zero. So at the final point, its velocity will be zero. Its final velocity will be zero. So what we have given, v equal to 0, u is equal to 126 kilometer per hour. Now change it in meter per second because distance is given in the meter. So s is equal to 100 meter. So u is equal to 126 into 5 by 18. So 3 6 18. Sorry, 6 3 18. 6 2 12, 6 1 6. Okay, 3 7 21. So you will get 35 meter per second as its initial velocity, and the distance is 100 meter, and we do not know the we have to find its retardation. So what is the formula in which all four variable can? That formula was v square minus u square equal to 2as. So v square minus u square is equal to 2as. V is equal to 0 minus u is equal to 35 whole square is equal to 2 into acceleration we did not know, and the distance is 200 meter. So minus 35 into 35 upon 400 is equal to the acceleration. So 5 7 35, 5 8 ja 40, 5 0 0. So 5 7 ja 35, 5 1 ja 5, 5 6 ja 30. So minus 49 upon 16 meter per second square will be your acceleration. So what is equal to, on solving you will get approx minus 3.06. Okay. So that was your acceleration, minus 3.06 meter per second square. Meter per second square will be the value of your acceleration. So what the next we have find what to stop with the stop. What is the retardation of the car and how long? How long means it was it was talking about the time. So v is equal to u plus 80. V is 0. U is 35. A is minus 3.6. 3.06 into time. So minus 35 is equal to minus 3.06 into t. So you will get 35 upon 3.06 into time. So approx you will getting 11.43 second as your answer. So that was the value of time. Now the next is define the term momentum. Define the term momentum and impulse. State an example. State an example. The law of conservation of momentum. The law of conservation of momentum. Law of conservation of momentum. So firstly, what is momentum? Momentum is defined as the product of mass and velocity. So what is momentum? Firstly, I will define it. So momentum is defined as the product of mass and the velocity. The product of mass and the velocity. The value of momentum will be m into v. It is be denoted by p vector. So it is a vector quantity. Its dimension is mass is measured in kg and velocity is measured in meter per second. So its SI unit will be kg meter per second. Now its dimensional formula. So dimensional formula kg is mass to the power 1, L to the power 1, T to the power minus 1 will be its dimensional formula MLT minus 1. So that was momentum. Now next is impulse. What is impulse? So impulse is a short force acting for a time duration. Force acting for a short time duration. So what is impulse? A large force acting for a short time to produce finite change in momentum. Okay, it is denoted by J. J is equal to force into time duration, or you can say that P final minus P initial. Its SI unit is force is measured in Newton and time is in second. And the dimensional formula of force is MLT minus 2 into T. So MLT minus 1 will be its dimensional formula, and it is a vector quantity. It is a vector quantity. So that was your impulse. Now, the next part will be your law of conservation of momentum. So, what is the law of conservation of momentum? Firstly, we have to state, then we have to give the example. So, law of conservation of momentum, it is it says that in the absence of external force, in the absence of external force, in the absence of external force, Initial momentum will be conserved. You can simply say that momentum will be conserved. Momentum will be conserved. Will be conserved. Or you can say that the total momentum, the total momentum of an isolated system, the total momentum of an isolated system of interacting particles remains constant if there is no resultant force, resultant external force, resultant external force acting on it. So simply, if the external force will be zero, so F external will be zero. So according to Newton's second law of motion, dp by dt equal to zero. If dp by dt equal to zero means if any quantity, if the derivative of any quantity is zero, means that quantity will be constant. So p is equal to constant. P is equal to constant means momentum will be conserved. Momentum will be conserved. Momentum is conserved. Sorry. Momentum is conserved. Momentum is conserved means the initial momentum is equal to the final momentum. Momentum conserved means P constant means the P initial is equal to the P final. When the initial momentum is equal to final momentum, so Mi Vi is equal to Mf Vf, or you can say that M1 V1 is equal to M2 V2. So that was your law of conservation of linear momentum. Means when no external force act on a body, so dp by dt equal to zero. So if dp by dt equal to zero, it means that p will be constant. P will be constant means p is conserved. For p conserved means that the initial momentum is always equal to your final momentum. So m1 v1 is equal to the m2 v2. And what are the example of it? So first example is motion of a rocket, and second example is bullet or gun motion. Okay. Now the next previous year question is, what is inertia? What is inertia? What gives the measure of inertia? What gives the measure of inertia? So what is inertia? The inability of a body, the inability of a body to change its state of rest or of uniform motion, to change its state of rest or state of motion by itself is known as inertia. And we have discussed earlier, now what gives the measure of inertia? Mass gives the mass is a measure of inertia. So mass is a measure of inertia. Next question is, wait a 1 minute. Next previous year question is, derive the equation, derive the equation S is equal to ut plus half at square from Vt graph, from Vt graph. Let a body moves along a straight line with initial velocity v, sorry, with the initial velocity u and uniform acceleration a, and uniform acceleration a, it attains the velocity v, it attains the velocity v in time t after the displacement s. Its velocity time graph is, its velocity time graph is, now I am drawing its velocity time graph. So this was the graph, that was your origin. Suppose a body moves to a certain distance with a speed u. After some time, it's attain a velocity v. So it cover after moving a distance av. That point is your a. Let me draw the point. First, that was your v, the final velocity. That's in time t, and that was your initial velocity u. Okay. So this point is a. This is b. This is d. This is c, and that point is your o. So from the diagram, OC equal to AD equal to D, and OA equal to CD equal to U. Okay, so that distance BD is equal to BD. BD is equal to BC minus CD, and BC is V and CD is U. So BD equal to V minus U. Okay, so displacement is, we know that the displacement is area under the VT graph. So displacement is equal to area under VT graph, means area of rectangle, area under VT graph. So the area under VT graph means area under OABC. So how we can divide it? We can divide it in two parts. The area of rectangle OADC and the area of triangle ABD. So the area under VT graph can be divided into two parts. Area of rectangle ADCO plus area of triangle ABD. Area of triangle ABD. So what is the area of rectangle? Length into breadth means you can multiply any length with the breadth. So what is length AO and multiply with OC. So AO into OC plus area of triangle is half base into height. What is base? Base is AD and height is BD. So half AD into BD. AD into BD. And in a LHS, there is always S. So the value of AO is U and the value of OC is T. So U into T plus half, the value of AD is T. The value of AD is T and the value of BD is V minus U. So we know that A is equal to V minus U by T. So AT equal to V minus U. So in place of V minus U, I can put AT. So U into T plus half T into AT is S. So S is equal to UT plus half AT square will be the displacement, the equation of motion. Okay. So student, that's all for today. In the next class, I will discuss some more question related to this chapter. Okay. Thank you everyone.